Hello, my name is Nicholas Volden, and in this video I'll be going a little bit more into detail about my implementation of the AES encryption algorithm for my CS122A final project. For the UART that was shown in the previous video, I used a file created by Timothy Goddard that was made available for anyone to use free of charge for whatever use to handle the actual transmitting and receiving of data. To control it, I had to create another Verilog file with a simple state machine to handle all the states, so it's idle waiting for an input or a transmit signal. Then it receives, and when that's done, it modifies the value and stores it, where it then waits to be transmitted through a transit signal, or it waits to receive another byte input, which would then overwrite the currently stored byte. For the encryption, I have another state machine, one state for each of the 4 steps in the AES encryption algorithm: the sub-byte step, the shift row step, the mixed column step, and the round key step. Each of these steps is implemented in a separate file, which is then all instantiated inside the main encryption module. Some of these are simple enough that did not necessarily need to be a separate file, but I put them in a separate file just to make it a bit clearer what is what, just make creating everything in the top file a bit easier and less confusing. So first is the sub-byte step, which is just implemented as a lookup table style way of doing it. So there's 256 options depending on the input. So then that is done for each of the bytes in the data, which is 16 bytes total. So to do that, I have a generate statement which generates 16 of the previous file, and then those are all run in parallel, which is one of the areas where an FPGA is really useful for this, because it can do all of them at once instead of doing one after the other, like it would have to be done in software. After that is the shift rows step, which is fairly simple. Depending on which row it is, it's shifted to the left, either 0, 1, 2, or 3. 0, 1, 2, or 3 bytes, and then it's wrapped around back to the right if it goes off. Then it's the mixed column step, which is then another calculations done for each of the columns at the same time. Then after that is the round key step, which with that it calculates the key that is then XORed with the current data depending on the previous round's key and the current round. And that is done, and that's XORed, and that gets the data, and then it goes back around and starts that again, doing everything for a total of 10 times. When that is done, the state machine goes to the done state, sends a finish signal, and it assigns the data to ciphertext, which is the fully encrypted data. And then after that, it goes back to idle, where it waits for more data, and when it's told to start, and it runs the encryption again. That's just a slightly more in-depth video about my implementation of the AES encryption algorithm. Thank you for watching.